In this video, I'm going to do an article review and critique. This is for my Paradigms of Inquiry course as a part of my PhD program in Educational Studies at the University of Cincinnati. And my name is Corey Larison. I am a physics teacher and I'm interested in the flipped classroom. So I use this model in my instruction. Basically, what I do is I have my students watch videos that I make the night before class, and then class is reserved for things like practice problems from a textbook, or sometimes we do labs, challenging activities, or various group work types of things. But the focus is on the content being delivered at home when students would typically be doing traditional homework, and then the more homeworky problem-solving stuff to be done in class. And this is so that students don't feel isolated and alone when they're working on the problem-solving portion of the physics classroom experience. And I found that it works really quite well. This is a really popular method. If you get on YouTube, there are a lot of physics-driven flipped classroom materials that is basically endless. And of course, my own content. Shameless plug, How to Physics. I started this YouTube channel this year. Basically, it's just hosting all of my video content for my students. Some of it is geared more for AP Physics students. Others of it is just general level. I've got a lot of work to do, but I'm really proud of it, so shameless plug. Anyway, the article that I'm going to be reviewing is by Susan Ramlo, or Sue Ramlo. And this article is entitled Student Views Regarding Online Freshman Physics Courses. Now, Sue is a professor at the University of Akron for the Department of Engineering and Science Technology, and I used this as a part of this article as a part of my master's dissertation, actually, and I really enjoyed it and have been reviewing it for this class. So to get started, the background, nationally, many public universities have started to move into the online course and program market that was previously associated with for-profit institutions of higher education. Public university administrators state that students seek the flexibility of online courses, but do students want to take courses online, especially freshman-level science courses perceived to be difficult? Yeah, so I love the background of this article. Basically, what Sue is doing is attempting to use a large research study that was done to answer specific questions from administrators who were trying to create online courses or online versions, or suggesting that online versions of physics courses should be created. And of course, this is taking place over the large backdrop of education that's been going on like the last 10 years with for-profit online universities that made killings when they were putting lots of advertisements online, you know, late night Comedy Central, things for people to get upward mobility. But it really started to affect the actual nonprofit, just university life, where more and more courses are being offered online, such as the course that I'm currently taking. So yeah, big paradigm shift going on right now, and is really useful today, you know, in terms of the pandemic. So the purpose of this study was to investigate student views related to the potential of a physics course that they were currently enrolled in, and whether it could be offered online. So basically what Sue was trying to do is to take the perceptions of students who are currently in a flipped physics class and organize them around the idea of how would you feel if this was not only a flipped class but a fully online class. And then this is going to be used to be juxtaposed, I guess you would say, with the administrator views who are saying students love online courses, and this is going to be great. The sample took place in a large public Midwestern university, involved students enrolled in their first or second semester face-to-face flipped class, like I had said, as a course for engineering and technology majors. Now, this is different from like UC's engineering physics classes typically have calculus. These are non-calculus based physics classes, and they're freshman physics students, they're non-majors, and there were 47 students involved in total in the study. And non-majors means non-physics majors. So now let's talk about the design and the methods. As you can see, this is a really complicated design and method. So let's just make it really small and then talk about it to the right with some bullet points. So the design and methodology is Q methodology. And Q methodology is super interesting. It is a mixed method And basically, what you do is you take a Q sample. So the Q sample is statements collected that eventually are going to be sorted. So the Q sample in this particular study was taken from interviews with students who would later do some sorting. So interviews with students in a flipped class. And then also in interviews with administrators about views about online courses. A lot of the statements from the administrators were taken from informal reviews or different emails and correspondence. They kind of make up the general perception of administrators. So 45 total statements. And then the statements are given to students who are being interviewed as cards, usually, and they are put into a Q sort. So there are a lot of different ways that this can be done. In fact, a lot of Q methodologists are trying to use different online versions of this thing, the Q sort and Q cards for the 45 statements. But here's basically what a Q sort is. So a Q sort looks like this. And what students do is they take these 45 statements that they have, are being given, and first they actually put it into 3 piles. The piles being most like my view, most unlike my view, and then neutral. Then students are asked to take those 3 piles and put them into this sort, where they're kind of, being able to like stockpile. Like, do you think that these 10 statements you're just neutral and you don't care about them? It's like, okay, well, you have 7. You can only have 7 of those neutral statements. So would you say that maybe this statement, online courses shouldn't be taught for STEM classes? Would you say that you really feel neutral about that, or is it on a +1 or a -1? Is it, sort of near or close to your view? And so what this asks students to do is basically take these qualitative observations and begin to quantify them in a sense. It's like an internal quantification. And then after these statements are sorted, unique factors emerge, or I guess they emerge from analysis by a program called PQ method. So PQ method is a software program. There are various extensions for things like R that you can use PQ method, but basically it is a statistical analysis tool that's going to take the factors based on their 0, +1, +2, +3, -1 scale, and factor them, see what kinds of patterns are emerging. And then these factors that emerge are qualitative statements that can be used to somewhat quantify the view of the group that is involved in the study. So for this study, what happened? Well, 3 unique student views emerged. One was titled Keeping It Real and Face-to-Face. This was the majority of students. This was the largest group. And basically, it just got to this idea that most students were favoring the idea of the face-to-face interaction. They didn't like the idea of losing face-to-face interaction, and they highly valued that. The second group were people that were a bit more neutral on whether or not an online physics class could work. And something that emerged out of this particular group was that they all had a caveat, like, sure, I would take the online physics class if I had to, or if it was offered, but I really wouldn't. I mean, if I took it or what I wanted to take would depend a lot on the course and the instructor teaching it. So I don't know, how heavy rate my professor is for the University of Akron, but it would come into play. If students are deciding if they're going to take an online course, then they're definitely going to check some sort of resource with friends or some outside influence to figure out, is this even a good professor? Because there's just not a lot of trust involved for professors making it. That was what emerged from that second group. And the third group was the smallest group. I think it was only 4 students from the study, and it said that online courses should just not be used for STEM classes. And so these were people that were just like very opposed to it and did not like the idea at all. So interesting, the first 2 groups, Factor 1 and Factor 3, the keeping it real to face-to-face and the online not for STEM classes, both groups were opposed, said that they wouldn't take courses if they were online. That was in their most like their view. They would not take those courses. Whereas the second group, again, on the fence, would or would not. But overall, there were no positive views that emerged, which is super interesting about the results. There was nobody gunning for online physics courses, even though they were in a blended physics environment using a flipped model. So there was a consensus among the different factors. Conclusions: the overall study said that students, so this is the consensus. Students' views were negative concerning having physics courses, especially labs, online, and those views conflict with the statements expressed by the administrators regarding students' desires for online courses at the university. Now let's get into the critique, because a lot of what I want to say about this article is just going to be in that critique section. So here's my critique. I think that this is a very pragmatic study. Q method is awesome, super pragmatic mixed method. And what's going on here is data transformation. So we're taking the qualitative statements of students and we are quantifying them so that they can be used to analyze. And in fact, in this study, the results section reads really well because it has that quantitative transformed nature to it, but then Sue brings back in actual interviews, statements from students to help clarify these factors and what they mean after they've emerged, which I really liked. And also, I love Q method because it allows for instrument creation. A lot of the studies that I read are using prefabbed instruments like the test for understanding graphs or kinematic understandings and things like that, or the force concept inventory. And those things are great, but it almost feels like played out, if you will. And also this allows for smaller sample sizes, which is a huge benefit for anybody that has very specific questions. And yeah, the more I learned about the Q method, the more I learned that there's this very strong community around the Q method with, I think Dr. Susan Ramlo goes by Dr. Susie Q. It's great. Just seems like a fun community. Another critique, I like that this answers a specific research question. So Sue has a specific question. Are the administrators right? Should we be developing online physics courses because they're popular and students want them? And they were able to go to their university and say, well, actually, no. We're seeing that our students don't trust this and they don't want that. So we should probably present this to the administrators like, hey, let's slow down a little bit. So a particular question from a particular administration. And also, I feel like this method is great for collaborative studies because you can get a lot of people involved in the statement making process, good teams. You can have a team conduct the actual interviews with students and the sorting, and another team working on the PQ method. Just seemed like a really good, there's like a lot of place for different people in this. So yeah, easy for research teams to handle. Challenges with the study that I see, and just Q method in general, really your instrument that you create works for your question. And so it's hard to apply this to other things. You have to say, like, this is a problem that we had or a question that I had, and this was my results from the Q method study. And then also, what if strong factors don't emerge? I was thinking that the whole time while I was reading this study, like, that's great that these factors emerged. What would happen if the factors didn't emerge? So yeah, that's definitely a challenge. And using interviews to explain the strength of factors, I put this as a challenge because if that's got to take a lot of work, because you're going to have to not only record the results of all the Q sorts and keep track of that data, but then you're also going to have to code all of the participants and then their interviews so that once the factors emerge, you can go back to those statements. So this just adds another layer of questionnaire and a little bit of difficulty. And then, of course, scalability. The sample size is necessarily going to be small, which it is a pro. Like, it's nice if you have a smaller community and you have a specific question, but harder to sort of scale up and say that, and therefore we should use this in all circumstances. So the answer for this administration might not be a good answer for another administration. And of course, those posh positivists who are going to poo-poo on the idea of this qualitative transformed into quantitative, it just doesn't work. And the reason why I put this as a major challenge is because in physics education research, there is a lot of quantitative heavy analysis of what works and what doesn't work, because it's a lot of people that are physics majors and they know stats or they know, eigenvectors and crazy stuff and they want to use it. So yeah, I feel like this is a bit more on the outlying paradigm for physics education research in specific. So what's my conclusion? Well, I'm interested in flipped physics research. As someone that makes video content for my students, I've made an entire year's worth of content for my AP Physics students, and I'm really proud of it. I think it's really good. I want to study it. I want to study specifically my AP Physics C mechanics students. That's hopefully what I would like to do for my my doctoral thesis. So for me, sample size is an issue because I only have, in my AP Physics classes, I'm fortunate to be able to convince a lot of students to take it. I usually have on average 50 to 60 kids a year take it. That's a very small sample size. But that means that I can be interested in mixed methods because that might be a good fit for me. Um, Ideally, I would like to do some kind of convergent parallel design, and this is, my big picture with a quantitative pre-test, post-test, maybe for one unit, or shoot, a whole year could be really cool with multiple pre-test, post-tests. And then I would bring in a predefined instrument. So maybe I would use something like the test for understanding of kinematics graphs, the TUG-K, or the force concept inventory. But I want to have like my own spin on this. I want to have something that I am making because I know my students and also I'm just interested in what they have to say. So I like the idea of a parallel qualitative study going on, and Q methodology I think could be really, really cool because I have high school students and they love doing stuff like this. We love whiteboarding and moving things around. I think that this would be a really fun, fast, and easy thing for me to do, which not all research teams have that as an advantage. So yeah, I want to make my own original instrument, develop statements, and I think that this would be a really great way to do a qualitative analysis. And maybe I could just do a Q methodology and avoid the whole convergent parallel design, but I think it would be nice to have some like some significant gains in student scores after using my videos versus a traditional class that I teach. And I can control that because the videos, they're me, they're my voice, they're my lessons. And so if I do those in person, that's easy to control for that. So I'd like to have that quantitative part and then mix it in with some qualitative. So for me, next steps after reading this article, getting excited about Q methodology, what do I need to do? Well, I should probably continue researching mixed methods for physics. Thus far, most of what I've looked at has been quantitative, and I'm just now starting to get into different accepted qualitative or mixed method designs, stuff that have little qualitative elements to them. And yeah, I think I should reach out to the Q method community. So if for some reason in the deep recesses of YouTube, Dr. Susie Ramlo, you watch this video, hi, I would love to learn more about the Q method community. You guys seem really fun. And I should attempt a practice Q sort with students for personal enrichment. I think this would be a fun thing to do with my kids, maybe after the AP test. Just come up with some statements that I think are nice, and yeah, just play around with R, download the PQ method for R, and see if I can start to figure out how factors emerge. And of course, I need to talk my advisor's ear off about all of this because I have to get my committee together and do my preliminary meeting, and maybe they're just going to look at me and say, this is a dumb idea, and I'll start all over. Anyway, that's my conclusion, my critique of this wonderful article by Dr. Susan Ramlo. The end.